Welcome to the Transrectal Ultrasound Mixed Reality Simulator. This compact unit can be used to perform simulated transrectal and transperineal ultrasound-guided TRUS prostate biopsy. It is dry, requires no fluids, and may be set up in 5 minutes from a padded case that meets checked airline luggage standards. The simulator contains an artificial prostate, anus, and rectal cavity, a virtual model and tactile feedback system, a tracking system, and a scoring and after-action review system. A tracked prostate biopsy gun and a tracked TRUS probe with a side fire or end fire guide is used. The virtual and physical models are based on scans of a real human. The virtual 3D model depicts soft tissue anatomy as well as a virtual representation of the needle and ultrasound probe. The bladder, rectal wall, and seminal vesicles exist only in the virtual environment. The virtual model is co-located to the physical model. This anatomical block is made to mate with the SMARTS platform. SMARTS stands for System of Modular Augmented Reality Tracking Simulators. The simulation shares the same components with our other SMARTS-compliant modular mixed reality simulators. The Visualization Mode button toggles the visibility of anatomical structures. One mode is ultrasound only, used to maximize clinical authenticity. The other mode is 3D visualization. It provides color images of the prostate, bladder, seminal vesicles, and patient position. The 3D visualization mode is useful for after-action reviews as well as introductory learning. The viewpoint of the virtual model can be controlled with preset of the virtual camera position or by using the virtual camera pointer, also called the tangible user interface. Hold the button on the controller for the virtual camera and move around the physical model. The virtual camera viewpoint will follow the controller and move around the virtual model. Release the button to freeze the virtual camera position. The simulated ultrasound images are generated in real time according to the position, orientation, and applied pressure of the simulated physical probe that is tracked in space. Markers show depth in centimeter increments. A sheet of red light depicts the ultrasound incidentating plane in the 3D visualization. The ultrasound has sagittal, transverse, and dual incidentating planes. These can be toggled with a button. The prostate biopsy needle is tracked in 6 degrees of freedom within the virtual model. The biopsy is simulated with an authentic click and is visible on ultrasound. You can also trigger a prostate biopsy with a voice command. The simulator includes custom cognitive aids that help instructors and learners use the simulator. Both visualization and auditory aids are used to assist. This cognitive aid is a needle stop line. This indicated the depth in which the user must insert the needle before firing. The user must meet the needle tip to the stop line in order to get the best sample. The stop line color of the needle is pointed at the target center. The stop line turns green for correct alignment and gray for misalignment. This cognitive aid is a projected core. It shows where your core will be taken based on your current position. It teaches both needle and ultrasound depth and positioning within the 3D view. This cognitive aid is the target sphere. The target sphere shows the location of the target on both the ultrasound and 3D visualization mode. It is used to help the user learn the correct location of the target in real time. The outer area of the sphere is light green while the center is dark green. This cognitive aid is the pain indicator. It helps remind the user that adjusting the TRUS probe while the needle is inserted in the patient can cause internal damage and pain to the patient. It does so by growing more red during movement and playing an audible noise. Just like the 3D visualization and camera controller, all the cognitive aids can be turned off during use and re-enabled during replay, or can be used live for teaching by clicking on the Guidance and Cognitive Aids button. All biopsy positions are saved. When you want to review, click the arrow keys and your biopsy positions will be displayed in order. The up arrow key shows all the cores from the current run at once. The virtual camera controller can be used to examine a replaying procedure from any new perspective. Cognitive aids that may not be used during the live performance can be activated during replay to aid self-debriefing. In overview mode can be viewed at any point by hitting the down arrow. This displays all cores placed without cognitive aids in red and all cores placed with cognitive aids in green for comparison. The simulator can automatically and consistently score sessions. The distance between core position and target is recorded for each attempt. After completing the procedure, the user can review this along with the error range, mean error, and standard deviation.